Good afternoon, class. The last lesson on graphs from this textbook. Hereafter we're going into revision. I think first simultaneous and then some revision we're going to do before the exam. Okay. At this point in our lives we were wrapping up graphs. Let's just get there. Right, we are number 5. Which page is this on? Page 71. Page 71. Show me. Close on that side. Alright. So the question is determine whether the points in 5.1, which is negative 2 and 1, lies on the graph of. So we've got 3y, 3y, this is 5.1, minus 2x is equal to 7. So what I'm going to do is I'm going to substitute the x in. If the y value is 1, then it lies on that graph. If it's not 1, then it won't lie on that graph. Does that make sense, people? So we're going to substitute x is equal to negative 2. So that's going to be 3y minus 2 times negative 2 equals 7. So what's negative 2 times negative 2? Positive 4 equals 7. You take it over the equal sign. So 3y is equal to 7 minus 4. What's 7 minus 4? 3. Divided by 3. So y is equal to? So does it lie? Yes. Therefore, negative 2 and 1 lies on y equals? No, what lies on? The graph 3y minus 2x equals 7. Does it make sense, people? You get 5.2. Again, I'm going to substitute. I could have substituted the y. If I substitute the y into be 1, then the x is negative 2, then it lies on. Can you see that, people? But I just substitute the x. Again, the equation is 3y minus 2x is equal to 7. So what's your x value you're going to substitute in? X is equal to 4. If it lies on the graph, if that point lies on the graph, then what would the y value be? 6. If you get any value other than 6, then does not lie. Make sense, people? So you go 3y minus 2 times 4 equals 7. So it's going to be 3y. What's negative 2 times 4? Negative 8 is equal to 7. You take it over the equal sign. So 3y is equal to 7 plus 8. What's 7 plus 8? Divide by 3 both sides. So y is 1. Does lie inside? Does lie in the graph? Therefore, 4 and 6, the point 4 and 6 does not lie on 3y minus 2x equals 0. Will you guys understand? Any confusion here? No. Number 6, same story. Okay? 6.1. So the equation is 5x minus y equals negative 3. So you're going to substitute x is equal to minus 2. So your 5 times negative 2 minus y is equal to negative 3. Negative 10 minus y is equal to minus 3. Negative y is equal to negative 3 plus 10, where 7 is minus y. Y is equal to negative 7. Is negative 7 the y value? Yes. So therefore, negative 2 and negative 7 lies on 5x minus y is equal to 8. You all okay with that? Let's do the other side. 6.2. You'll substitute. X is equal to half. So 5 times half minus y is equal to negative 3. 5 times half is 5 over 2. To get over the equal sign, so negative y is equal to negative 3 minus 5 over 2, which is negative 11 over 2 is negative 1. Divide by negative 1 both sides, so y is equal to 11 over 2. Does it lie in the graph? No. Why? Because why? Negative 11 over 2 is not the same as negative half. You all agree with that, people? So therefore that one doesn't lie in there. Number 7. Number 7. There's also common ask questions here. It says if point K, which is point K and negative 5 lie. Now you are told that it does lie on the graph. We mustn't prove it's lying on the graph. Or test whether it lies. They are telling us it lies on the graph. So what we do is we substitute K and negative 5 into the line which it lies on, which is 2x plus 4y equals 8. You don't have to write that down. Okay? So what we do is we say this is a x and a y. So here x gets a k. So it's 2 times k plus 4 times negative 5 is equal to 8. 2 times negative 5? Negative 20. Take a 20 over 2k is equal to 8 plus 20. 8 plus 20? 28. Divide by 2. So your k value is 40. Does it make sense, people? Yes. Easy, no? Your last exam without a calculator, no? Maths. Next exam you will be allowed to calculate. There's no next term. No? Start getting your scientific calculators ready. Okay. Warm it up so long, make sure the batteries work. Okay. If you didn't buy a calculator yet, you don't know which calculator you must get. You know how the calculator must look, no? Like your friends. Alright. Here we are told if 3 and A and B and 2 lies on the line y is equal to 2x, you must find A and B. Okay? We find A and B. So what we do is we substitute 3 and A into y equals 2x plus 6. So there's an x and a y. So we got A is equal to 2 times 3 plus 6. What's 2 times 3? 6. And 6 plus 6? 12. So A is 12. You see that, people? On the other hand, we're going to substitute B, which is B and 2. Again, both these points lies on the graph y 2x plus 6. This is x and a y. Can you see that? Yes. So you got 2 is equal to 2 times B plus 6. What's 2 times B? 2B. Take 6 over 2 minus 6, negative 4. Divide by 2 both sides. So B is equal to negative 2. Okay. Number 9. If y is equal to 4x plus 2 is parallel. People, if lines are parallel, what do we know? Gradients are equal. So we got y is equal to 4x plus 2. Y is equal to ax plus 7. The gradient is read off if it's in the form of y is equal to mx plus 7. Now, is the first equation in that form? Yes. Yes. So what's the gradient on your first line? Your first line, the gradient is 4. The gradient of the second line is 8. So therefore, if lines are parallel, gradients are equal. That's all you have to write. The gradient is going to be, sorry, they want the value for A. Okay. So therefore, this is the reasoning we're using. Therefore, A is equal to 4. Lines are parallel, gradients are equal. Let's look at the last one on the board. I'm sure there's more. Determine B if. So the one is y is equal to bx minus 1. Is it in the form of y is equal to mx plus c? Yes. So what's the gradient of this line? B. And the line is parallel to 3x minus 2y. Is that 3x minus 2y in the form of y is equal to mx plus c? No. So we must get it in that form. How? By taking 3x out. So minus 2y is equal to minus 3x plus 4. And you get y on its own. Divided by negative 2 throughout. So y is equal to negative divided by negative. Positive. 3 over 2x minus 2. Is it now in the form of y is equal to mx plus c? Yes. So if lines are parallel, gradients are equal. Not so? So therefore, B is equal to 3 over 2. Because that is the gradient of the second graph. The gradient of the first graph. Right, you guys understand? Any confusion there? So now we look at number 12. In question 12, we are asked to determine the equation of f and g. So if I'm looking at f, do I have 2 points as lying on f? Yes, I have. But what's the coordinate of this point here? Negative 2 and 0. And the other one? 0 and 3. So how do I determine the equation of a straight line? Must be in the form of y is equal to mx plus c. How do we calculate m? y2 minus y1 over x2 minus x1. Remember, if I make this x1, that's y1, x2, y2. All agree with that? Gabby? You're sleeping behind your pencil bag. You can't see the board behind your pencil bag, I'm sure. You can see through your pencil bag. So what do we have? 3 minus 0 over 0 minus minus 2. So it's going to be 3 over 2. Is that? This 3 is supposed to be negative, isn't it? Otherwise not going to be a good representation of what's happening here. There must be minus. Just make that effect that change there on your work there. It should be minus. Because this is on the negative part of your y-axis, not so? It must be minus. So what's my equation reading now? Y is equal to minus 3 over 2x. And what is C, people? C is normally your y-intercept. And what is your y-intercept here? What's your y-intercept here? Negative 3. So that's going to be negative. So this is the equation of f. Okay, that's the equation of f then. Now, you see for g, the equation of g of x. These lines are parallel, so what do we know? Gradients needs to be the same. So the gradient of the first line is equal to the gradient of the second line, which is equal to minus 3 over 2. So what's the equation now? Y is equal to negative 3 over 2x plus c. And c is your y-intercept, not so? What's your y-intercept here on this graph? 1. Can you see that, people? Right, it cuts your y-axis. That's going to be 1. And that's a graph of g of x. You all okay with that? The next question in 12.2. We are asked to determine the coordinates of A. People, what is A here? It's your X-intercept. How do you calculate X-intercept? With y equal to 0. So remember that is on the equation of g of x, and this is the equation of g of x. Can you see that, people? So we say 0 is equal to negative 3 over 2x plus 1. You take it over the equal sign. So 3 over 2x is equal to 1. Divided both sides by 3 over 2. We will divide both sides by 3 over 2. So x is equal to 1 divided by 3 over 2. The same as saying 1 multiplied by 2 over 3, which is 2/3. Have I answered the question? No, they want the coordinates of A. So therefore, A would be 2 over 3 and 0 is. Alright. Take this off, I need the space. Determine the equation of AB and CD. So you're looking at AB. Do I have 2 points on this graph? Yes, I do. The 1 point is Q, which is negative 1 and 0, and 0 and 1, which is this point here. Okay? How do I determine the equation of a straight line? Will be in the form of y equals mx plus c. How do you calculate m? Gradient, change in y over change in x. y2 minus y1 over x2 minus x1. Again, if this is x1, y1, x2, y2. And make it a habit of labeling it so that the examiner can see what you are doing. Shiloh, my girl. Sit up straight, please, if you don't mind. You had 2 days off, you had a weekend, but you're sleeping now. I have 1 minus 0 over 0 minus minus 1. So you're going to give you 1. Can you see it's an increasing graph? Yes. So the gradient is positive. So the equation now is y is equal to 1x plus c. But what's your c value? C is your y-intercept, not so? And what's your y-intercept? 1. So y is equal to x plus 1. Okay. Hello? Right, that is not lost. Alright, so y is equal to x, which is 1, and your c value is 1. Can you see that, people? So it's y is equal to x plus 1, or 1x plus 1. So this is the equation of line AB. Okay, that is the equation of line AB. Now if you're looking at line CD, what do you notice about line CD? It's parallel to your x-axis. So anywhere on this line you have a constant y value of 3. So what's the equation of CD? What's the equation of CD? Y is equal to 3. Looking at the next question. Okay. Look at the next question, 13.2. Determine the coordinates of P and Q. Okay, we know what Q is. Q is negative 1 and 0. However, P, as we know that P is lying on the line of CD. Anywhere on the line of CD, there's a constant y value of what? 3. So in other words, P is going to be some x value and 3. This is your Q value. Let's not put your Q is going to be negative 1 and 0. No? This is now for question 13.2. So if you're looking at P, we said it's going to have a consistent or constant y value of 3. Now remember, when we put the x in, we get the y out in an equation, not so. So what I'm going to do is I'm going to substitute p, which is x and 3, into the equation of CD. Can you see that? AB, sorry. Why? Because why? That P lies on that line as well. Can you see that? Yes. So if we do the substitution, this is X and a Y. So you go, this is a Y, it's going to be replaced with 0. So 0 is equal to 1 times X. Sorry, your Y is 3. So it's going to be 3 is equal to 1 times X plus 1. You take that over the equal sign, so X equal to 3 minus 1, which is 2. Therefore, P is going to be 2 and 3. Okay. It's important to understand these type of questions, okay? So it comes in all the time. (13.3) What is the equation of the line perpendicular to CD? So perpendicular means to say what? 90. It's at 90 degrees. And it's going through 1 and 5. So if I look at x is 1, it's approximately there. Y is 5, approximately there. So that's 1 and 5. If it's perpendicular, it's going to do that, not so. If it's perpendicular to the CD line, then that new line will be parallel to the y-axis. So it will have consistent x value. Consistent x value of x is equal to 1. Okay. This is your interpretation questions on the graphs. Right, number 14. In number 14, we are told determine the equation of the line, which is the first one cuts the y-axis at 2 and have a gradient of minus 1. That one is easy. Y is equal to negative x plus 2. There's a gradient of negative 1 and the y-intercept of 2. 14.2 passes through 14.2. It passes through 3 and 2 and has a y-axis of minus 2. Which means to say your C value is negative 2. Not so. So the equation of a straight line is in the form of y is equal to mx plus c. So mx minus 2. Now to calculate m, I need another point on this graph, which is 3 and 2. You can do the substitution of this here. So you substitute 3 and 2, it's a x and a y. 2 is equal to m times 3 minus 2. Take it over. That gives us 4 is equal to 3m. Divide by 3. M is equal to 4 over 3. So the equation they're looking for there is y is equal to 4 over 3x minus 2. That is that graph there. 14.3. says has a gradient of 3, so y is equal to 3x plus c, and passing through the point negative 1 and 2. That's x and a y. So 2 is equal to 3 times negative 1 plus c. That's negative 3 becomes positive 3. Y is equal to 5. So it's 3x plus. Okay? 14.4. It passes through the points negative 5 and negative 1 and 4 and negative 3. So again, here we are told, remember, your gradient is changing whatever change it is. Your gradient, y2 minus over x2 minus x1. So this is x1, y1, x2, y2. So it's going to be minus 3 minus minus 1 over 4 minus 5. That's going to give you negative 2 over negative 1, which is 2. Your equation is y is equal to 2x plus c. You substitute one of the points in, x and a y. Negative 1 is equal to 2 times 5, which is 10, plus c gives you negative 11 once you take a 10 over. So y is equal to 2x minus 11. The next one. (14.5). Lines are parallel, what do we know? Gradients are the same. So it's parallel to this line. So gradient 1 is equal to the gradient 2, which is equal to, what's the gradient of this line? So half. So y is equal to mx plus c, so it's a half x, and there's a y-intercept of negative 2, so that's your c value. Number 15 and 16. Number 15 says complete the table if it's given that. So from here, calculate your corresponding y value. Okay? You're given the x value of 0 here. So you substitute x is equal to 0 into the equation, which is minus 4x plus y equals negative 2. So wherever you see x, you put a 0. So negative 4 times 0 plus y is negative 2. That gets dropped. So y is negative 2. Okay. In the next case, we have a y value of 2. So you put 2 where you see y. Now you substitute y is equal to 2 in there. So negative 4x plus 2 equals negative 2. Take it over the equal sign. Negative 4x is equal to negative 2 minus 2, negative 4. Divided by negative 4 both sides, x is equal to 1. Okay, next one. You substitute x equal to minus 1. Negative 4 times negative 1 plus y equals negative 2. That's going to give us positive 4. Take it over becomes negative 4. Y is negative 6. Next, you could substitute y is equal to 0 now. Negative 4x plus 0 equals negative 2. So negative 4x is equal to negative 2. X is equal to last one. We'll substitute the x value of negative half. So we got negative 4 times negative half plus y equals negative 2. What's negative times negative? 2 going to 2 once, 2 going to 4 twice. So it's 2 plus y equals negative 2. So y is equal to negative 2 minus 2, negative 4. Okay. Number 16. Determine the value of k if 2 and 1 lies on the graph of the equation kx plus y is equal to 2. Again, that's a x and a y. Not so? So we'll substitute 2 and 1 into kx plus y equals 2. So x and a y. So you say k times 2 plus 1 is equal to 2. So 2k is equal to 2 minus 1, which is 1. Divided by 2k is equal to number 17. Determine the equation f, g and h. We did one like this already. This is the last sum. No. Are you looking at F? Back to those points, not so? The point is 0 and 2, negative 2 and 0, not so? Yes. Gradient is y2 minus y1 over x2 minus x1. 1. So y is equal to, what's your y-intercept on the line of F? What's the y-intercept? 2. So y is equal to mx plus c. So y is equal to 1x plus c, which is 2. Yes? Just hang on. This is now F. Now G is this line here, not so? Well, those lines are parallel. What do we know? Gradients are the same. So if the gradients are the same, M1 is equal to M2, which is equal to, what's the gradient of F? What's the gradient of F? 1. So what's the gradient of G? Also 1. So y is equal to 1x plus c, and what's your c value on G? Negative 1. H. You see H is parallel to the x-axis, so it's going to have a consistent y value. And there's a consistent y value of negative 2. Okay. Next question. The question says, determine the coordinates of A and B. If you look at A, well, A is what? X-intercept. What do you do for X-intercept? Let y equal to 0. So you see this line, A is lying on G. So I can only use the equation of G, which is that there. So x-intercept at y equal to 0. So 0 is equal to 1x minus 1. So that over becomes negative x is equal to negative 1. Divided by negative 1, x is equal to 1. Ever answer the question? No. So A is going to be 1 and 0. If you look at B, looking at B, we're looking at B. B is on this graph here, not so? Yes. What is your y value of B? It's on this line here, so that has a consistent y value. Negative 2. So it's x at negative 2. So you'll substitute x at negative 2 into the equation of g of x, or g. Why? Because our B is also on the line of g. Can you see that? Yes. Okay, it's also on this line here. Okay. So the g of x equation is again this here. Remember, that's a x and a y. So there's your y. So negative 2 is equal to 1 times negative 2 minus 1. Nope. It's negative 2, I have to substitute x. So negative 2 is equal to 1 times x minus 1. You take it over the equal sign. Negative 2 plus 1 is negative 1. So therefore B is going to be negative 1 and negative 2. Okay. That is very similar to what the questions that we have done here. You first work out the equation using those 2 points, and then you substitute the coordinates of A and B in afterwards. Is that the end of it? Yes, okay. So we'll stop here. Don't forget you're writing a test tomorrow on this work, no? So on this and Pythagoras. I'm just going to fetch your money for your photos now. Sorry? Yeah, it's a class test. Then we're going to do some simultaneous equations in tomorrow's lesson, okay?